Today we're going to talk about ellipses. This is section 7.4. And you might know ellipses as ovals. And when we talk about ovals, or an ellipse, we're talking about a set of all points such that the sum of the distances let's say to the foci is constant. Let me show you what this looks like. An ellipse would look something like this. Something like that. And maybe center would be like over here. So that would be a horizontal ellipse. And we could have a vertical ellipse. The difference in the equations would be if it's horizontal, the equation would be x minus h squared plus y minus k squared is equal to 1. And we would have a squared here and b squared here. We'll talk about what those mean. If it's vertical, the difference in the equations would be we'd have y minus k, we'd have x minus h squared here plus y minus k squared is equal to 1. But in this case, a squared would be under the y and b squared would be under the x. The difference between a squared and b squared is that a squared is always bigger than b squared. And let's talk about what those letters represent. So, a represents the distance from the center to the endpoints. This is called the major axis. On the major axis, we have the foci. So it's different than a parabola because we have two foci. And the distance from the center to the focus, we use c. And then the last thing we have to talk about is the minor axis. Let's see, maybe we could use purple for that one. The minor axis runs perpendicular to the major axis. And that distance would be b units. All right. The length of the minor axis would be b plus b, or 2b units. the length of the major axis would be A plus A, would be 2A units. Now it's the same for both horizontal ellipse and a vertical ellipse. And then the only other thing that we have to talk about is the equation that ties together A, B, and C. And that equation says that C squared would equal A squared minus B squared. It's actually similar to the Pythagorean theorem. If you actually were to take a look at this relationship where you have any point on the axis, let's see here. All right. You could make a right triangle, and that right triangle would give you the identity that C squared is equal to A squared minus B squared. So what we'll do is let's take a look at some examples, and we'll go over everything that you need to know. First example, let's graph x squared plus y squared over 25 and 16. And then we'll find some components. Now the difference again between the horizontal and the vertical is wherever the bigger number is. Remember, A squared is bigger than B squared. So if the bigger number is underneath x, it's horizontal. If the bigger number is underneath the y, it's vertical. In this case, the bigger number is underneath the x, so it would be horizontal. Now the center, if you go back to the formulas, it kind of looks like a circle. There's no number here, so it's really x minus 0 and y minus 0. The origin would be the center. And we know the bigger number is 25. Well, that means A squared is 25 and B squared is 16. So that means that A is plus or minus 5. I mean, the length would just be 5. And the B value would be 4. Because this is horizontal, we're going to go out 5 units horizontally. And the minor axis would go the opposite direction. And the minor axis I used purple. So that is our ellipse. Let's connect the dots. And we'll find some other components. What if I asked you how long is the major axis? Well, the formula for the length of the major is 2A units. Well, if we know A is 5, 2 times 5 would be 10 units. The length of the minor would be 2B units. B in this case is 4. So we get 8 units. I could ask you, what are the endpoints of the major axis? And the way that we do this is we start with our center. And remember, the major axis goes left and right. So we're going to the left 5 and to the right 5. So we're adding those to the x value. The endpoints of the minor axis, we're going up and down for that. So you take your center, but you would be adding and subtracting 4 to the y value. And then the last thing I would like us to find are the coordinates of the foci. And in order to do this, remember our formula was c squared is equal to a squared minus b squared. And what we're going to do to find the foci, we know that a squared is 25, b squared we know is 16. So that would mean that c is equal to the square root of 25 minus 16 is 9, or c would be 3, which means the foci would be right here. 3 units to the right and 3 units to the left of the center. The coordinates of those foci, you always start at the center, but because we're going to the left 3 and to the right 3, it would be 0 plus or minus 3. All right, let's try another one. What if we had a problem like this? Graph x minus 2 squared plus y plus 7 squared equals 1. We'll put 9 here, and we'll put 4 here. Well, the bigger number is underneath the y, so we know it's going to be vertical. And looks like our center would be 2 comma negative 7. And our a squared is 9, which means the a value is 3. B squared is 4, which means our b value is 2. So because it's vertical, we're going to be going up 3. 1, 2, 3. We're going to be going down 3. And those represent the endpoints of the major. You could just leave your answer like this. We always start at the center, but because we went up and down 3, we're adding 3 to the y value. The length of the major is 2 times a units, which is 6 units. Let's work on the minor now. The endpoints of the minor because it's a vertical, we're going to the right and left for the minor, the opposite direction. We're going to the right 2, and we're going to the left 2. I went a little too far. Connect your dots, and you have your parabola. It's a vertical ellipse. To get the endpoints of the minor, we write our center. And because we went to the left and right, we're going to be adding and subtracting 2 to the x value. The length of the minor would be 2 b units. And the last thing we have to find would be the coordinates of the foci. And remember, if c squared is equal to a squared minus b squared, a squared is 9, b squared was 4. We know that c would equal the square root of 5. And that's always going to be on the same axis as the major axis. So we're going to write our center, and then we're going to add plus or minus root 5 to the y value. All right, we'll do one more. Write the equation of the ellipse and let's see, it looks like we'll center it at 0, 0, but we will go 4 units out this way. 4 units out this way. We'll go up 3 units. We'll go down 3 units. All right, so let's set it up. And the center is 0, 0, so I mean you could say x minus 0 squared here, or generally people just put x squared and y squared. The tricky part is, it's horizontal, so our a squared is going to be on this side. Our b squared is going to be under the y. It looks like the larger number we're going 4 units this way, we're going up 3, so the larger number is 4. That's what a would be. 4 squared is 16. 3 squared is 9. So that's how you would do something like that. All right, so for homework, what I would like you to do is on page 436 to 37, I'd like you to please do numbers 6 to 8, 10, 12, 15, 23, and 25. All right, thank you. Have a nice day.